Okay, so now we will try deriving Vieta's formula for quartics. So this is how our casual quartic equation looks like. Ax to the power of 4 plus bx cubed plus cx squared plus dx plus e equals to 0. Okay, so yeah, let's eliminate a because coefficient of highest degree is always 1. Not always, we usually write it so that it's 1. So let's divide whole equation by 1 over a. Now our new equation is x to the power of 4 plus b over a x cubed plus c over a x squared plus d over a x plus e over a equals to 0. Okay, so now as we know highest that our highest degree is 4 now, so it's 4 now, so like there must be 4 roots, 4 linear factors. The 4 roots are x equals to alpha, our first root, x equals to beta, our second root, x equals to gamma, our third root, x equals to delta, which is new one, and our fourth one. So let's write them as a linear factor: x minus alpha, x minus beta, x minus gamma, x minus delta equals to 0. Now, if we were to expand these linear factors, we should be able to get our original equation back, right? So let's try that and compare it with our original equation. So I'm gonna expand them directly because it's like getting very long. So it would be, let me change the color. You guys will see how long it is. So let me start from here. So x to the power of 4 minus alpha plus beta plus gamma plus delta plus alpha beta plus gamma delta plus alpha gamma plus beta gamma plus beta delta. I forgot to write x cubed, x squared. There is more, so x squared, so minus alpha beta gamma plus alpha beta delta plus beta delta gamma plus alpha gamma delta. It's last one plus alpha beta gamma delta equals to 0. So this is our expansion, which is like very long. So let's first write them as summation before comparing. So x to the power of 4 minus summation of alpha. This is why the summations are always useful. So plus summation of alpha beta, because pairwise sum of roots, so x squared minus now triple pair of sum of roots, so alpha beta gamma, and lastly plus alpha beta gamma delta. Now let's compare it with this. Let me copy and paste it. Okay. Okay, so now as you guys see, summation of alpha is equals to b over a. So let's write that down. Okay, summation of alpha, I forgot to write minus, it is equals to b over a. Now, summation of alpha beta is equals to c over a. So let's write down that as well. Summation of alpha beta is equals to c over a. And summation of my negative summation of alpha beta and gamma is equals to d over a. So let's write down as well, write down that as well. So minus summation of alpha beta and gamma is equals to d over a. And lastly we have alpha beta gamma and delta product of roots is equals to d over a. So alpha beta gamma delta is equals to e over a. So let's make what's negative a positive, like summation of alpha sum of roots is negative. Let's make it positive. So sum of roots alpha is equal to minus b over a. This is our first beta formula for a quartic. So now this is our second one. We don't need to make this negative. So pairwise sum product is pairwise product of sum is c over a, and then we need to make this negative, negative or positive. So summation alpha beta gamma is equals to minus d over a. So this is our third one. So triple product pair of some, whatever you want to call it, is equals to minus d over a, and product of roots is equals to minus positive e over a. So these are our four formulas. Now let's try and implement them in a question. So let me grab the question. Yeah. So our first question is 2x to the power 4 minus 7x cubed plus 3x squared plus 10x minus 8 equals to 0. We need to find summation of alpha, summation of alpha beta, summation of alpha beta gamma, and lastly alpha beta. Okay, if you guys forgot, this basically means sum of roots alpha plus beta plus gamma plus delta. This basically means pairwise product of sum of pairwise products. So alpha beta plus beta, each of them will get multiplied by each other once. And similarly here, triple pair sum product, whatever you want to call it, and this is product of roots. So let's write formula for each. This is minus b over a, this is c over a, this is minus d over a, and lastly this is e over a. So let's write the values for a and b. So a equals to 2, b equals to minus 7, c equals to 3, d equals to 10, e equals to minus 8. So sum of roots will be 7 over 2. Okay, input 7 instead of b minus 7, and 2 instead of a, 7 over 2. And product of pairwise product of sum of pairwise product will be 3 over 2, and product of triple pair product of roots will be minus d over a. which is minus 10, and 2 divided by 2, which is minus 5. Now lastly, product of roots e over a. E is minus 8, a is 2, minus 8 divided by 2, which is equals to minus 4. So this is our question number 1. Now question number 2. Question number 2. Okay, this is a different one. So question number 2. Let me actually write it down. Construct the Quartic polynomial whose roots satisfy. Now let's write them down. Alpha plus beta plus gamma plus delta is equals to 10. Sigma alpha beta is equals to 35. Sigma alpha beta gamma is equals to 50. And alpha beta gamma delta is equals to 24. Now using this, we have to construct a polynomial, a quartic polynomial. So as we know that this is how our polynomial looks like. X to the power of 4 minus sum of roots, x cube plus pair sum x square minus triple sum, and lastly plus product. So yeah, let's input these. This is sum, this is pair sum, this is triple sum, this is our product. So if we were to input these values, our equation would be x to the power 4 minus 10 x cubed plus 35 x squared minus 50x plus 24 equals to 0. So this is it for today's lecture. And in the next one, we will be looking at recurrence and then substitutions. Then we will be done with our chapter. We will then move on to past papers.